Okay, let's start talking about the I2C communication realized in embedded Linux system. For the I2C communication, we know it's a very basic communication in embedded system. For the embedded system, we choose the Linux, but for Linux, how to realize the I2C communication, we should choose a microprocessor. You know, uh, many Linux systems running on some embedded platform. You know, in the market, we know the Linux, Yocto, and some other microprocessors like Samsung. Yeah, so we choose IMX.6 or the microprocessor or the base microprocessor. Simply because IMX.6 is very popular in the current market. Uh, Before we start the episode, I introduce myself. This is my name, and this is my email address. If you have something to discuss with me, you can send me this email. Actually, maybe you can hear that my English is not that good. I'm a new immigrant to Canada, and currently I am living in Toronto. So I will try to speak very slowly to make everyone understand me. Okay, let's start. Uh, for the I2C communication realized in Linux system, we choose the IMX6 microprocessor. Actually, we will explain it as three steps. First of all, we will explain what the I2C is. Even though I2C communication protocol is very simple, we still need to explain it. This step is only about the communication protocol itself. You don't need to consider much about the registers of IMX6. That means how to control and configure registers to generate the I2C signals we expect. Don't consider much about this. And then, of course, you don't need to consider anything about the embedded Linux system. Yeah, that is the most difficult step, but that is the final step. So after we figure out what the I2C communication is, we will go to the second step. That means, how to control the registers. Which bit you should write 1, which bit you should write 0. So different values in the registers will generate the signals of I2C. And how to configure some registers, it can help us generate the interrupt when the transaction is completed. Yeah. So this is the second step. But for the second step, we still don't need to consider about the operation system. When we have a clear image about the first and the second steps, we can go through the code, the Linux kernel code about this part of IMX6. So this is our flow. So let's go to the first step. What I2C or what does I2C is? You see the topical. How does I2C work? I2C contains 2 lines. It's very simple. Each line has a pull-up resistor. It connects to the high voltage, for example, 3.3 volt. The 2 lines, one is called SDA, the other is called HCL. HCL we talk firstly. Why? It's very simple. It's a regular rectangular wave. It's a clock signal. It's a clock, and SDA is a date. The date, it's not only the date itself. It consists the address, command, and the data itself. In I2C protocol, the address contains 7 bits address, and after the 7 bits address, following is the command bit. The command bit is only 1 bit. If the bit is 1, it represents read. If the bit is 0, it means writing. Yeah. So the SDA contains not only the data itself, but also the address part and the command part. For the communication, we know we have read data. The reading data is launched by the I2C adapter. I2C adapter is actually the I2C host, and the reading launched by the I2C adapter. Reading is launched by the I2C adapter, and the I2C slave will will respond the date the I2C adapter expected. But the basic unit is line bits. But what about the basic unit is among the transfer? So we will explain after this page. Except for this, you see, on the two lines there are three devices. The first is one I2C adapter. The others are two slaves. Okay. Yeah. So just now we talk about the basic transfer unit is line bits. Why? Let's talk about this. When the I2C adapter write some data to the I2C slaves, firstly, it will send out the first 7 bits address, and following the address is the writing bit. Writing bit is 0. So the first 8 bits consist of the first byte from the first bit to the 8th bit. The first 7 bits are address. The 8 bits are the writing command. The writing command is 0. So this is intact byte. And this byte is sent from the I2C adapter. When I2C slave received the first byte, it should give an acknowledge bit. The acknowledge bit is the length bit. So the whole line bits constructed the basic unit, basic transfer unit. After that, the I2C adapter will send the real date, the real byte, the first 8 byte, and then to acknowledge this, the I2C slave will respond one acknowledge bit. Yeah. For the acknowledge bit, I will talk some sentences. The acknowledge is always low. What is low? For the SDA line is active, is high level. When the slave, I2C slave, acknowledge this bit, it will pull down it to 0. So 0 is the correct acknowledgement. Just now that is writing. So when we talk about reading, but no matter writing or reading, the I2C adapter firstly send out the first 7 bits address, and then the 8th bit command bit. Command bit is read is 1, so the first 8 bits consist of 7 bits address plus 1. 1 is read, and then I2C slave will send out the acknowledge bit on the line speed. Yeah. And then after that, the I2C slave will send out, actually it will respond to the byte, the first byte, 8 bits. After the I2C master receives the first byte, receives the 8 bits, it will send out the acknowledge bit to the I2C slave to acknowledge this byte, the first byte. Yeah. Except for this, we can see the first picture, the above picture. For the communication, it starts. It begins with the start singular and end with the stop singular. You see, the left is start singular, the right is stop singular. Start singular, that means SDA is pulled down before the SCL clock appears, and the stop singular means SDA line is pulled high after the SCL clock disappears, except for the start singular and the stop singular. We can see this in the middle of the picture. That represents 1 bit, the effective 1 bit. For example, you see the singular is the clock, SCL clock is a regular clock like this. Yeah. For this, you see, in the middle, when SDA want to represent the 1 bit, the bit 1, you see the above line is 1. This line will cover the whole area of the SCL. You see my mouse moved to the area. Yeah, this is line, and the bottom is 0. So the is longer than the SCL's area. It covers the whole area. Yeah. So let's take an example. The first is the start singular. Of course, actually in our register there is 1 bit we should set. From 0 to 1, it can generate the start singular. When it is clear from 1 to 0, it can generate the stop singular. Yeah, this is the start singular. And then the first 7 address, you see, the 8th bit is command bit. Read is 1, W is 0. So the first byte, you see, have been sent out. So the slave will give an acknowledgement bit. Actually, the SDA is always low. You say low. This is acknowledgement corresponding clock. Yeah, the line. And then the first byte, 1 to 8 bits. The line is the acknowledgement for this byte. And then the second byte and the second acknowledgement. Okay. Maybe you can repeat the third byte and the third acknowledgement, the stop singular. Yeah. So we summarize. Start singular is the first, and then 7 bits address, and command bit. Read is high, W writing is low, acknowledge bit pull to low. This acknowledge bit is from the I2C slave. No matter reading or writing. Yeah, we can understand it. Yeah, of course. For the real data, if it is reading, okay, the acknowledgement is from the host. If it is writing, the acknowledge bit is from the slave. You say actually 1 byte and ACK bit. Actually, the basic unit 1 byte, you know, are 8 bits, and the ACK bit plus 1 bit is a basic transmit unit in I2C, is a basic transfer unit in I2C. So the next episode we will talk about how to configure the IMX.6 registers to realize the I2C communication. That's the next episode.